Really quickly, this is called Lesson 4. If you look at my handy-dandy little outline here, how many lessons are there in this unit? 7. It's not a very long unit, mostly review. So let's see. Monday is a Pro D day. I don't see you Monday. So I'll be doing Lesson 5 on Wednesday. I would imagine the following Friday is probably the Monday schedule. That would make sense. So I'll probably be doing Lesson 6 there. And then I'll see you the following Monday. I'll be doing Lesson 7. You can expect your test to be towards the end or so of that week-ish. I almost always try and do a tutorial, if I can, after school, the day before the test. However, for the record, what's my website? If you go to my webpage, pitmath.com, and you click on Physics 12 links, and you take the time to scroll down about that much, okay? Well, if you scroll a bit further, here are also the ultimate review package that I gave you, answer keys. They're also online elsewhere, but if you can't remember where they're there. But if you click here for some tutorial videos, you'll see I've got tutorial videos for almost everything, and they're pretty in-depth. Here's the kinematics one. It's about an hour long. Oh, it's almost up to 3,000 hits. Apparently that one's doing fairly well. 13 likes, no dislikes. Ooh, I got some game here. If you're working after school, if you have sports or something like that, you can use these, and I will try and post the tutorials. The only issue is because usually I'm doing the tutorial the day before the test. If something goes wrong with the technology, and something sometimes does, I won't get that one up in time, or it may take me until 9 p.m. to get it up and online. Maybe the network is down or whatever. So don't quite gamble on always being able to get them. But I have got tutorials, and in fact, I think I've done 3 kinematics tutorials. What I usually do is I put the main one on the web page, but also I'll email you out the other ones as we get close with the links as well if you want to watch more.
What are the tutorials for? Do you go through like the
whole course, whole unit. I generally start out with any questions from the big review, and then I try and give some hints about the test for people that give up their free time and stuff like that. You'll find out in about 2 weeks, because that's what it'll be. Also, just a reminder, going back to my PitMath webpage, if you miss a handout, click here. What block are you guys? Block A. We're doing Unit 1. The trick to finding if you missed something is to actually hit date modified. If you sort by date modified, whatever was most recent is now on the top as opposed to alphabetical, because not everything I hand out is alphabetical. But you will also see there is a review answer key for the kinematics review. We're going to be actually doing some questions from the kinematics review today as well. The famous river question, a lovely application of vectors. An observer, it says, is standing on the shore of a river. He sees a boat traveling across the river. While the boat's engine is pointing the boat directly across the river, the current is pushing the boat sideways. So I think what's happening is this. The boat is pointing this way, and the current is pushing it sideways like that. Does that make sense? It says the boat's velocity with respect to the shore is 8 meters per second at an angle of 65 degrees with the shore. What does DULP stand for? Draw a little picture. I'm going to cheat because my artistic skills are terrible. So there's one shore of the river. You can freehand it. There's another shore. There's the river. Let's decide the current is going to the right, since that's a nice friendly direction. So I'll draw a little arrow, and I'll say V. What do you think the C stands for? Current. Makes sense. Now let's draw a little picture of the boat. Which way is the boat pointing? Read carefully. Boat's pointing directly across. So I'm going to go like this then. Here is the velocity of the boat's motor. I'll call that Vm. And apparently, I can combine these. How would I add these together, one wonders? Oh, so Jaron, if I hear you correctly, and I think I do, I think what you're saying is if I go if I go, boy, this pen's not working well. Motor and current, the resultant with respect to the shore would be that. This is great. Oh, and they gave me a velocity. Which velocity did they give me in the question? How big? 8. Which one of those three is the 8? And I'll give you a hint. I think you can figure it out based on the comma afterwards. I think it's the resultant, isn't it? Because when they say comma with an angle of 65 degrees, I think, Shay, I'm pretty sure they're saying, hey, that one's the 8. This one's a little different. Usually we found the resultant here. Actually, no, they gave us the resultant. And they gave us an angle with the shore. They gave us that angle there, which is a problem. You see, that angle is not in my triangle. I did geometry when I taught Foundations of Math 11 last year. I have been told that in pre-calculus, you folks are no longer doing any geometry. So when I say alternate interior Z angles, you have no idea what I'm talking about, Chelsea. A few of you do, but most of you don't. I need to teach you a useful skill. Put your pencil down, watch. For what it's worth, if you have two parallel lines like that, pretend those are parallel. Okay, let's try it again. Mr. Duke, a little better than that. If you have two parallel lines like that, and you have a letter Z, can you see the letter Z? Boom, boom, boom. This angle and this angle are the same size. And you can prove it by going yoink. If this angle is 65 degrees, how big is this angle right next to it? 25. How big is this angle up here? 90. How big is what's left? 65. You could put a 25 there. I like to try and use the angle that they gave me. On my answer keys, you'll notice I'm in the habit of whatever angle they give me, I'll find where it is in the diagram somewhere, and I'll use that same angle. So if you want your work to look like my work, we call this alternate interior angles. Or I think Mr. Gerard, when he used to teach it, used to call it zangles, because the kids would just remember if you got a Z, those are the same. You know what? That's 65 degrees right there. Oh, and for two of you, told you this will be useful in physics next year. We've barely begun to scratch the surface. What are they wanting us to find in part A? Current. Okay. Based on my diagram, that there current there, opposite, adjacent, or hypotenuse? Adjacent, let's put a little A there. The 8 is what I know, so the 8, opposite or hypotenuse? Hypotenuse? Which trig function has the A and the H in it? Okay. How fast is the current? I think it's going to be cosine of 65 degrees equals current over 8. I'm pretty sure the current is going to be 8 cos 65. You get 3.38. Okay. Is that to 2 or 3 sig figs? Then I'm good with that. 3.38, what, units? Meters per second. Cool. Did they ask for a direction? I think how fast implies speed implies scalar. Certainly for part B, they use the word speed in the question. I'm pretty sure Terry there will go for a scalar. We don't care about the direction. What are they asking me to find, Terry, in part B? Were you late? I don't care about you then. Chelsea, what are they asking me to find in part B? How fast is, sorry? Which of those velocities that I've got labeled on my little green diagram are they wanting me to find? Well, I just found the current. They told me the resultant. What's left? The motor. How fast the boat is being pushed across the river. Okay. VM, opposite adjacent to hypotenuse. Which trig function? I can't remember if it was in this class that somebody said, Mr. Dewick, is it always going to be tangent? If someone asked in this class, I said, it's often going to be tangent, but this is a great example of one of the rare times where it ain't tangent. Which trig function? Now, I could do it with tangent. I could use the current. If I was a good test writer, which I am, why would I choose not to do that? Yeah, I might have got A wrong. I'm always going to hedge my bets. Unless it's a huge time savers, I will always try and use what they gave me. There will be some times when you have no choice. Or if I have a choice, I'll do it both ways if I have time and check my answer. And if I get the same answer both ways, I know I'm right. Woohoo! So sine, you say? Sine of 65 equals motor over 8. I'm pretty sure the motor is going to end up being 8 sine 65. Did I go on a good calculator rant at the beginning of the year? Yeah? Because if you have a good calculator, you might just be able to go back arrow and change this cos to a sine and be done. 7.25 meters per second. That wasn't a huge time savings, Ben, for that short equation. Trust me, sometimes this year you'll be thankful if you can. I'm only changing one number and I can read you the whole... Oh, great. C. Tyler, what's C asking me to find?
How long does it take?
Read the whole thing, first of all.
If the river is 256 meters...
Stop. They just gave me some new data. What did they give me?
River.
Let's go label that on my diagram. How about way over here? Let's go like this. This is 256 meters. Now keep reading, Tyler. What are they asking me to find?
How long does it take to cross the river?
What is that? What are they asking me to find when they say how long? Oh, let's write down T equals question mark, because now my question is no longer blank. What else do I know? Oh, that's probably why they gave it to me. When they say if, it probably suggests that I need it to solve it. Okay. How can I solve for time? Oh, I think I can use this. Plus a half AT squared, but John, let's assume A is 0. So I need the velocity. What's my velocity? Now, I heard half the kids say 8, and I have to lovingly freak out on them. We are in vector land now. Look at my picture. Look at that 256. What direction is it? Vertical? Then don't you dare use a slanty velocity in a vertical distance. That's garbage math. We're in vector math now. Alicia, our directions have to match. So look at my picture. What direction is that displacement, that 256? Vertical. Once I say it that way, now it's obvious. Which velocity do I have to use? What's the only velocity that's in the same direction? Look at my picture. The motor. The motor. In fact, you know what? Let's be really, really clever. I want in my notes to remind myself of the importance of direction, and I could write distance vertical and velocity vertical in my picture, but we came up with a lovely abbreviation last year for vertical and horizontal. We used single letters. Do you remember what they were? How about the letter Y for vertical? And I'm going to remind myself that it's going to be vertical distance and vertical velocity. And I want the vertical velocity from my diagram, which you said was the same as the motor, which was, 7.25. The most common mistake on this is kids put a slanty velocity in with a vertical displacement. Don't you dare! Now we're in physics 12. Now we're going to be going at angles. Direction is going to become hugely important. Direction, 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 direction. Mr. Duke, why are you getting so worked up? Next unit, we're starting projectiles, and we're going to break everything up into horizontal and vertical components. Does anybody remember what the vertical acceleration was in free fall last year? This one you probably still have memorized. What was your acceleration? Negative 9.8. What was the horizontal acceleration of a projectile? Do you remember? 0. Do you know how many kids want to put that negative 9.8 in there this year? Because the questions are going to get more complicated. And they want to put an acceleration in there. Don't you dare put a vertical into a horizontal. A lovingly freak. Snap. Calm down. Tyler, what are they asking me to find? My speech I hopefully got through. What are they asking me to find?
Time? How long
Get the t by itself.
T equals D over B.
Now,
No.
you're right. Now, I strongly encourage you to learn the equation solving. If you want to see me lovingly freak out, if you're someone who is still drawing this silly thing, I'll snap. I'm not a big fan of that because that only works for 3 letters. What if there's 4? You got to learn a whole new shape. What if there's 5? You got to learn a whole new shape. Well, you know, I'd rather teach you one method. Did I tell you that things can move diagonally? That you can. We worked on this last year, Mr. Kamosi and myself. We hopefully taught you how to manipulate equations because you're going to be having some equations that have 8 variables equals 7 variables. What shape you going to draw for that one? So I'm not I know they do it in Science 10 because at that point most of you suck at math, but what was it?
T equals D over B.
Yeah. I got sloppy. I dropped the y on the y because I think I reminded myself, but I would have no problem. You put it in there as well. What did we say the distance was? 256 divided by, what was the velocity that matched our distance? 7.25. Now, even though I wrote 7.25, since I noticed that I still have that 7.25 stored on my calculator, I'm going to use my answer button. I'll always be as exact as I can. If I have an answer stored, I'll use it. And I get 35.3 units. What did we just find? Time? Yeah. Hopefully you clued in why we emphasized memorizing units last year. Cuts way down in your thinking. Time, seconds. D. Jaron, can you read D to me, please? Oh, you were late. Never mind. I don't care about you. John, can you read D to me, please?
How far down the bank of the boat has moved when it reaches the far side?
What's it asking me to find?
DX.
Ooh. Did you hear him? I thought I was going to have to coach him towards it gently. I even like the way he said that. In fact, yeah, I think what they're asking me to find is if the boat started right there, how far down it's going to drift. So you know what? I'll write down dx equals question mark. What am I going to need to find the displacement? What do I know? I'm probably going to use Vx, which was, I think, in my original diagram, the current. Was it not, Jason? How big is the current? I've scrolled down. Let's use our, since we're using calculations, I would not use a rounded off answer here, right? So 3.38 at least is what I'll use. And you said time. Is that why they had me do C first? Hopefully you clued in Physics 11 last year that often will give you a part A, B, C, and D, and you better go in order. Don't be trying to skip to D. You probably have to do A, B, and C to get all the information for D. Hopefully you also learned if you were unable to get part C, you would have made up a reasonable time for part D if you knew how to do it and still showed me that you could do it, and I can still give you full marks for that part of it because you're good test writers now, right? Time was 35.3. Again, we're assuming no acceleration. I need an equation that has distance, time, velocity. Oh, good gosh. This is the crappy grade 10 equation that they give you that really is bad. In Science 10, do they give you d equals vit plus a half at squared? I don't think they do. Oh. Teach it properly. Don't teach half of it. And the boring stuff, constant speed. Oh, for Pete's sakes. Let me press down on the accelerator once in a while. Vx 3.38 time 35.3. I'll write that and I'll type 3.38 times, I'm going to use my answer button again because it's not 35.3, it's 35.30809, whatever. 119.3, oop, 119.3 would be the 4 sig figs. Mr. Dewick said this year, to cut our corners, we're going to go 2 or 3 sig figs. 119 meters. E. Suppose, it says, you want the boat to land directly across from its starting point. What direction should I point the boat in order to travel in a straight line relative to the shore, and what will the resultant velocity be? Well, if I look at my original diagram, will I have to point the boat to the left or towards the right? Jason? I'm going to have to point it into the current. So I'm going to draw a little picture here. I think what I'm going to end up doing is I'm going to be pointing the boat this way. We have to make an assumption here because the question isn't clear. Diana, we're going to assume the boat's motor speed is the same as part B, that they're holding the accelerator, the throttle at exactly the same amount. So I'll call that V motor again. And we're going to combine that with the current. How do I add those two vectors together? Draw them. So when I draw them, there's the motor. And then put your pencil down for 1 second. How do I know not to draw the current that long? Or how do I know not to draw the current that short? How do I know that I have to draw the current exactly that long? Even better than that. Even better than that. I know what the resultant is supposed to look like because the question told me. What do they want the resultant to look like? Straight up across. So I'm going to keep drawing the current. I'm going to stop when that's going to guarantee that I get a resultant straight up across. That's how I know to stop exactly right there. Okay. What was the current again? I've gone to the next page. 3 point something? 3.38. And what was the motor? 7.25? First of all, let's find the angle. Now, they want the straight line relative to the shore. There's the shore. I think the angle that they want is that one. What's the problem with that angle? It's not in my triangle. Do you remember my little speech about Z angles that I just showed you a few minutes ago? I'm pretty sure that angle is the same side. It is the same side. Okay. So if I'm finding this angle, which is the same magnitude as that angle down there, Alicia, the VC, opposite adjacent or hypotenuse? I totally agree with you. You're the queen. How about the 7.25 VM?
The opposite?
Isn't it?
The hypotenuse.
Yep. And by the way, I'm glad you did that. It's usually tangent. It's usually opposite and adjacent. This is that rare example now where, you know what? The resultant that we're finding isn't the hypotenuse, is it? So, common mistake. You said it was a hypotenuse? Which trig function? Shay, which trig function?
Cosine?
Yes. What always goes next to the trig function? The angle theta. And apparently that's 3.38 over 7.25. What's the angle with respect to the shore? 62 degrees? That's the magnitude. Now, how would I do the direction? Well, you could throw a compass onto your diagram, in which case it would be north of west. You could say above the shoreline. You could say above the horizontal. Because the original question didn't give me a diagram, I'm reluctant to affix or to stick a north, south, east, west one on here. On your test, I will give you a picture, and you'll notice in the review package, they give you a picture. It's amazingly tough to do the graphics. When I first typed this up, I didn't have a tablet. Now I could probably do the graphics easily, and I keep trying to remember to draw a picture where I said DULP, and I keep forgetting to. Anyways, I'm just going to say 62 degrees. That's not all they wanted. What else did they want, Chels? Okay. How can I find VR? Oh, can I use Pythagoras? Except instead of going a squared plus b squared equals c squared, I think I'm going to go c squared minus b squared equals a squared square root. I could also do trig, but if I did the trig, I'd be using an angle that I just found what might be wrong. So I'll use Pythagoras. 7.25 squared minus 3.38 squared equals square root. You get 6.41 meters per second. Oh, how long would it take this person to cross the river now? I didn't ask that, but can I figure it out? Is that a vertical velocity that we just found out? Do I know the vertical displacement of 250? You know what? If I go 256 divided by that, that's how long it'll take him to get across. A little longer, but he's not drifting downstream, so that might actually save him time, or her time. Okay. The other question we love, replace river and boat with crosswind and airplane. And especially this part E, hey, there's a crosswind blowing and you want to go to New York. What direction do you want to point your plane so that your plane flies straight to New York? So they use it in real life. Except in real life, Jacob, as it turns out, the Earth also rotates underneath. Is it Jake or Josh? Is that right?
Jacob.
It is Jacob? Or Jake?
Jake.
Jake, yeah. I'm still learning names. At least I got the Jake right. Jake, in real life, the Earth actually rotates and curves underneath the plane, so it's much more complicated than that. Okay? Handy hint number 1. If I ask you for a change in anything, that's always going to be final minus initial. During this year, I'm going to be asking you to find, well, the change in voltage. You know how you'll find it? Voltage final minus voltage initial. I'll ask you to find the change in momentum. You know how you'll find it? Momentum final minus momentum initial. I'll ask you to find the change in flux. You know how you'll find it? Flux final minus flux initial. But many of them will be vectors. If they're in a nice straight line, you just subtract them. If they're not, how do I find the change and how do I subtract them? I don't. How do I subtract two vectors, Josh? Add the opposite. Okay? So handy hint number 1 is that. Handy hint number 2. Direction, 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 direction. If they give you a vertical distance, you better use a vertical velocity in the same direction and a vertical acceleration when we get there in the same direction. If they give you a horizontal distance, you better be using a horizontal velocity and a horizontal. Everything must be horizontal. Why don't I care about time? Because time is a scalar. Okay. What's your homework? 1, 2, 3, 4, 8. And then it says also you can try blah, 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 blah. Actually, this is not quite right. From the great big review package, the ultimate review package that I gave you, that thick one, if you don't have it, I have a couple extra copies. From that one, you can start, because we're only 4 lessons away from finishing the unit. Here are the questions that you can start from there. Click, copy, click, paste. From the review package, you can do numbers, and you can write this down, or you can circle them on the pack. Yeah, it's easier just to write them down on the homework. From the review package, you can do number 1, 2, 4, 6, 11, 13, 15, 17, 19, 20, 21, 24, and 30.